Hi everyone, welcome to the channel. In this video, we will see answers to assignment 5 of the week 5 for the NPTEL course of Operating System Fundamentals for the July to October 2024 session. So let's get into the video. The first question is, assuming we are running an application on a system with 4 processing cores, this application has both serial and parallel components. Also assume that 60% of this application is executed in parallel and 40% of the application is executed in serial. Based on the Amdahl's law, this application gets a speed up of what? So they are asking the speed up based on the Amdahl's law, and the options given are 1.30, 1.42, 1.25, 1.81 and 1.20. So the formula for speed up is equal to 1 by s plus 1 minus s divided by n. 1 by s plus 1 minus s divided by n. So the s and the 1 minus s divided by n are in the numerator. So here n denotes the number of processing cores and s denotes the serial component. So if we substitute the value, this value of the serial component is 0.4. So in the formula, we'll get 1 by 0.4 plus 1 minus 0.4 divided by n, which is 4. So you'll be getting 1 by 0.625, which is equivalent to 1.8181. So the answer would be 1.81 times. So the right answer is D. The next question is, the many-to-one multi-threading model supports what? So the options given here is many user level threads only, many kernel level threads only, one user level thread and many kernel level threads, many user level threads and one kernel level thread, many user level threads and many kernel level threads. So in the relationship between user level and kernel level threads can be represented by using different type of models like many-to-one model, one-to-one model, and many-to-many model. So many-to-one model means many user level threads are mapped to one single kernel level thread. So the right answer to this is option D, many user level threads and one kernel level thread. Next question, which of the following multi-threading model is unsuitable for multi-core systems? So the right answer to this is many-to-one multi-threading model in which many user level threads are mapped to one single kernel level thread. This is unsuitable for multi-core systems. The next question, which of the following multi-threading model blocks the entire process if a thread which is a part of the process makes a blocking system call? Many-to-many, many-to-one, many-to-partial, one-to-many, and one-to-one. So the answer to this is many-to-one model blocks the entire process if one thread makes a blocking system call. Next question, which operating system does not support the many-to-many multi-threading model? Solaris, HP UX, True64 Unix, iRix, and Windows 11 operating system. So the Windows and the Linux operating systems supports the one-to-one model. So one user level thread is mapped to one kernel level thread. So Windows and Linux supports a one-to-one model, so they do not support the many-to-many multi-threading model. The right answer to this is Windows 11. The next question is, which system calls allow the calling thread to wait for another thread to terminate? So the pthread underscore join system call allows to wait for the thread to exit. So the right answer to this is option C. The next question is, which of the following statements about non-preemptive scheduling is not true? Option A, once a process starts executing, it runs to completion before another process can begin. It is simpler to implement compared to preemptive scheduling. It can lead to longer waiting times for processes with short burst times. It allows the operating system to preempt a running process to give CPU time to a high priority process. It is commonly used in batch processing systems. So it is non-preemptive scheduling. So in option D, you have it allows the operating system to preempt a running process to give CPU time to a higher priority process. This is in the case of priority scheduling. So here in non-preemptive scheduling, as the name says, it will not allow the OS to preempt a running process. So the right answer to this is D. The next question, which of the following is not the task of the dispatcher? Dispatcher saves the context of the currently running process. Dispatcher restores the context of the next process to run. Dispatcher helps to switch the CPU mode between user mode and kernel mode. Dispatcher manages the main memory for process scheduling. Dispatcher provides the control of the CPU to that process which is selected by the CPU short-term scheduler. So dispatcher gives the control of the CPU to the process selected by the CPU scheduler. So dispatcher manages the main memory for process scheduling is not the task of the dispatcher. So the right answer to this is option D, because it is done by the memory management module of the operating system. The next question, choose the correct option for FCFS scheduling algorithm. FCFS means first come, first serve scheduling algorithm. It ensures the shortest average waiting time. So now that is wrong. It is a preemptive scheduling algorithm. That is also wrong. It guarantees maximum throughput. That is incorrect. It uses a priority queue to manage the process. That is also incorrect. And so the right option for FCFS scheduling algorithm is it suffers from convoy effect, which is nothing but a shorter process behind a longer process. Next question, which of the following is not a criterion to evaluate CPU scheduling algorithms? Throughput, response time, memory usage, turnaround time, and waiting time. So the CPU scheduling criteria are throughput, turnaround time, CPU utilization, waiting time, and response time. So memory usage is not a criterion to evaluate the CPU scheduling algorithm. So that's all about week 5, assignment 5 for the course of operating system fundamentals. See you in my next video. Until then, take care. Bye-bye.